All right, so I'm more than excited to do this. How many of you are excited about React 19? I need shouting, not hand raising. Excellent. So what we're going to do in next 40 to 45 minutes is like we want to explore things in and around and beyond React 19. And these two gentlemen beside me, you got their introduction, but however, I would like to start with Sathya. If you want to tell a little bit more about your background first, like what you do in Meta. I know that you are doing in the compiler stuff, but a little bit more about it.
Yeah, for sure. So my name is Sathya. I'm a software engineer at Meta. I'm part of the React core team. And like you said, I've been working on the React compiler for the last 3 years almost now. And we just open sourced it at ReactConf a couple of months ago. Yeah, that's me.
How do you, Naman?
Hi, I'm Naman. I've been at Meta for 7 years. I'm on the design system team. We make the components that go into Facebook.com and some other websites. And I've been working on StyleX for like 5 years. We open sourced it in December. It's our CSS and JS library. It's also compiler-based. It's a Babel plugin, but it's a much simpler project than the React compiler. It's just
Awesome, awesome. All right, so we'll get to StyleX, but before that, about React 19, because people are so excited. That's what we saw. My first question to you, so we are excited about React 19. How much excitement should we have? And what kind of preparation we need as a developer who have been doing on React for quite a while? Because since I started with React, it's probably the first time I'm seeing this amount of excitement. Is kind of phenomenal.
Yeah, definitely. This is the release where server components is going stable. So that's really exciting for us. We've been working on server components for a long time. And this is the first release that's stable. So that's the big talking point. Apart from server components, there's a bunch of other features that fit into the story of server components, like form actions, for example. They work really well with server components. And then there's optimistic UI that we added support for with a hook called user optimistic. And then there's a tiny little new operator called the use operator that we added. Not a lot of people know about it. It's very underrated, but I love it. And then for me, the most exciting part is the 19th release unlocks the React compiler. So the React compiler doesn't ship with 19, but the React compiler uses a hook. And that hook is provided by the 19th release. So with 19, you'll be able to use the React compiler once the React compiler goes stable. Yeah.
I want to mention one more thing because it goes under the radar a lot, which is ref is finally just a regular prop, and you don't need forward ref. That's probably the biggest DevX win in the short term.
That's kind of a relief, actually. That's something we are really waiting for to use. But a question that comes: are there any breaking changes that we need to be worried about or need to consider in React 19?
So we have a page with all of the things you need to do to update. I don't think it's a big update. There are some breaking changes. I think, yeah, I will refer back to the React release to look at the changes. But yeah, I don't think there's huge changes here.
Cool. Yeah, I think one thing I want to mention is if you've been using the modern patterns, there are no breaking changes. It's more like, yeah, refs are finally just a prop. So if you're using string refs in some class components from 10 years ago, yeah, that will stop working. But hopefully you're not doing that anymore.
That's cool. I'll go back to StyleX now. So you mentioned briefly about StyleX in your talk. If you could give more insight to it, I guess that is something that we use as a paradigm for Facebook, WhatsApp, and more other Meta apps, right? So,
yeah, okay, so StyleX started about 5 years ago when we were working on a big Facebook.com redesign and rewrite. It was actually when we rewrote all of Facebook.com to be built with React, and StyleX was the styling solution that was made for that. And for the first few years, we just like modified StyleX to fit our needs and to scale to Facebook scale. And then it was so successful and people liked it so much that my managers and others were like telling me to work on open sourcing it, and other products within Meta, such as Instagram and WhatsApp, started reaching out, and like they started adopting StyleX as well. So as of today, pretty much all the desktop websites that we have at Meta are all running on StyleX for the styling. This even includes like Threads and Meta AI. Like the new stuff is pretty much 100% StyleX. Some of the older screens have a mix of the old code and the new code. And what it is it's essentially a CSS and JS library from a developer point of view. It's similar to Emotion or stylesheet.create from React Native. But what makes it different is that unlike traditional CSS and JS that has all of these performance trade-offs where you have to rely on runtime injections of styles and things like that, StyleX is based on a compiler. So it generates a single static CSS file at build time. So you have the same performance as like handwriting CSS in a separate file, but you get all of the benefits of CSS and JS, including like composing styles, passing them around components, and just deterministic resolution.
So you mentioned about CSS and JS, and I have to ask this. So what's your own view about CSS and JS? Because when it came, right, CSS and JS, there were a lot of mixed view, like when CSS JS was there. What's your thought, and how you started with it, and how do you see it today?
Yeah, so I think CSS and JS was misunderstood a little bit because the whole point of putting CSS in JavaScript was never about the runtime characteristics of it. CSS, being a static file, is better for performance, and we've always known that. And the early CSS and JS libraries that actually inject CSS at runtime, they all have a performance bottleneck, and the fact that they were often fast enough kind of tricked us into using it more than we ever should have. And I think why I'm happy that StyleX is now open source, and also why I'm happy that things like Tailwind are getting lots of popularity in the community, is that it's finally what CSS and JS should have been, which is you get to write your styles in your JavaScript code with your components co-located in the same file. And you get all of these other benefits of having JavaScript as a language, where you have namespaces, you don't have like these, you don't have to deal with global namespaces, you don't have to deal with conflicts. These are the things we wanted by putting CSS in JavaScript. Right. But we never wanted all of those performance problems, and the compiler with like StyleX is one way to fix that. There's some similar-ish solutions that are all build time. Like Tailwind is essentially a build time tool, and Panda CSS is a build time tool. So yeah, I think it's the correct model if you have the right performance characteristics.
Got it, got it. So I'm sure that many of us would like to know about React compiler. And when you first about compiler, I always feel like compiler is something which take the source code, take out the bytecode. What is React compiler is about? What is inside?
Okay, yeah, let me actually give a background. Like, has everyone here heard of the React compiler? Okay, quite a lot of people. That's actually, yeah, that's great. For those of you who are not aware of the React compiler, so you know how in React we just work with regular JavaScript objects, they just plain values, and when state changes, the React component re-renders. That is the philosophy of React. It's a function. Your UI is a function of state, right? That's the fundamental idea, and everything just follows from that. But one of the problems with this is sometimes you could re-render your component more than necessary. So you could compute more values unnecessarily if your component re-renders. And to fix this, well, the computer science way to fix this is to cache the values, right? And React has a bunch of hooks for exactly this. So there's the use memo hook, there's the use callback hook, and there's react.memo. And they all help with memoization. So you don't have to recompute values that haven't changed and React memo will, or React.useMemo will only recompute if the dependencies change. So there's a dependency graph that you build in. But the problem now is you have to think about memoization as a UI developer, right? You don't want to be thinking about all of this. You want to build your product. You want to build your UI. That's what React has been great default, right? Like you don't have to think about anything else. You just describe declarative UI, and React just makes it happen. And that was the selling point for the VDOM. And it's actually great. So with the compiler, we were thinking, okay, so we have this use memo hook. We have these hooks, and they provide some mental overhead for developers to think about. That's taking time away from the UI. What if we could like automate this? What if the compiler could actually understand your React component code and understand the JavaScript specification, and then model a computation graph and know what is the dependency for each value that's in your component? So the compiler actually does all of this. So you don't have to think about use memo or any memoization. The compiler will just run ahead of time. It will like take your React component code, lower it. I mean, it ships as a Babel plugin for now, but we actually do a fairly sophisticated compiler analysis. There's a lot of work done to make sure we follow the rules of React, for example. So the compiler then spits out a component, like the same component, but memoized. So with the compiler now, you don't have to think about re-renders, for example. So that's the idea behind the React compiler. And we've been thinking about the React compiler for a long time, almost like 10 years now. In fact, the first attempt at building a compiler was on class components, like 8 years ago, maybe more than that. That's when we actually built it and then tried to ship it. But we ran into a lot of issues with class components. Like, for example, like this keyword was too dynamic, and the compiler couldn't understand it. And that actually motivated the design for function components and hooks. So hooks and function components are not only great for developers, they actually help the compiler. So we've been thinking about this for a long time. And then the recent React compiler is the latest iteration of the compilers. And this is something that we have shipped at Meta, and we think we're at a state where we can open source and have people in the community try it and give us feedback. So it's like it's been a long journey for the React compiler.
Great. So it means like no more use memo, use callback for us once React 19 is coming up, right? We don't have to use probably, if you're writing a new code.
Yeah, so it is a bit tricky. Like the compiler is actually smart enough. So if you have code that already use memo and use callback, the compiler will compile that component without taking in the use memo use callback. It'll compile it as though it doesn't have the use memo use callback. But then once it compiles the code, it'll compare the compiled code with the original code, and it'll see, hey, is the use memos the same? Like, have I compiled correctly? Or has the user actually added more use memos? And it'll see if the user has added more use memos, then it won't compile that. It'll be like, hey, maybe the user knows more than me. I shouldn't be compiling it incorrectly. And then it will stop. So this helps with like correctness. We've seen some people depend on memoization for correctness as well. But then if you're using memoization just for performance, yeah, the compiler will just take care of all of that. You don't have to think about use memo use callback at all. The compiler can actually memorize more than developers can, because, for example, use memo use callback has to follow the rules of hooks. So it has to be at the statement level. So everything has to be, you can't cache a value inside a conditional or after like an early return, right? But the compiler actually doesn't compile to use memo. It compiles to something that's more lower level. So it doesn't need to follow the rules of hooks. So it actually memoizes more than what was previously even possible. The compiler also will memoize JSX elements, which previously no one did, because that was just, it gets too cumbersome if we have to memorize everything. And then some other pattern that we noticed was we actually shipped it on an app that was very heavily optimized. Like we had several engineers go in, optimize the app by adding use memo, use callback. And then we were like, okay, there's not going to be any improvement. It's going to be the same. We actually saw a big improvement in that as well. So it turned out that the performance improvements were done, And then they saw improvements, and then they went away. Like the engineers went on to do other things. And then someone new joined the team, and then they just passed down a new prop without memorizing that prop. So all of the performance work the engineers had done was lost, right? So this is the problem with memorization is you have to constantly think about it. And with a compiler, you don't have to do that. The compiler is going to constantly run on every change. So the compiler can memorize more. So you don't have to definitely think about use memory callback.
So one thing extra that, like other than performance, that the compilers helped out a bunch, like building components for the design system, is we've noticed that the deep understanding of the code that the compiler has, it has discovered bugs in our components. So you may sometimes be breaking the rules of hooks and might not realize that you're doing that. And previously, to catch these subtle bugs would basically be impossible for an ESLint plugin or something. And the React compiler is so sophisticated that it's revealed a whole bunch of really subtle bugs where you won't see it in practice most of the times, but 1% of the time something is breaking in production. And it caught all of those, revealed them, and we were able to fix them.
Yeah, there's a ESLint plugin that we ship with the compiler. Is anyone using the ESLint plugin? Okay, some of you are. I would recommend more people to adopt the ESLint plugin. It helps you write better React code. It's not for the compiler. It's for developers to write React code. So the React compiler, like I said, understands React. So it understands the rules of React. For example, the component has to be pure. You can't modify props. You can't modify state directly, right? Things like that. And it has built-in analysis and validations to check if you're modifying props. And it will complain and be like, don't do this. This is breaking the rules. And the rules are not for the compiler. That's the best part, actually. I actually joined the team without knowing a lot of React. And when I learned the React programming model, that's when it clicked for me. It's oh, this paradigm is so good that it helps, the fact that the pure functions help with building better composable UI, that's the main part of it. And making it, this pure functions also make it really good target for compilers was just an additional benefit, right? So that's why this functional UI paradigm is so good.
Awesome, awesome. So I guess React compiler is with a lot of promises, right? Are you guys happy? Yes. Let's clap. So,
this was done by a team of 4 people, not just me, but I'll take all the credit.
yeah, great to, you and all of us who worked behind it. So, in this year ReactConf, I was watching the video on YouTube, and you mentioned about React Strict DOM. And today in your talk also, I saw a glimpse of it. Yeah. So what is it about, and what is empowering?
So there's this project that is widely used. I don't know how many people here use it. It's called React Native for Web. Can you raise your hands if you've used it or heard of it?
Oh,
okay. So React Native for Web basically lets you write React Native code and let you share that same code on the web. And the way that it does that is it has a bunch of shims and JavaScript code to run all the things that exist in React Native on the web. But over time, we basically realized that the web has more constraints than native in some ways. We need to be able to serve or render web apps, but not native apps for good performance. And to be able to do something like that, we need to be able to use CSS features like media queries or pseudo classes like hover. And so we realized that React Native for Web is a great convenient tool to share code between web and native, but it causes some compromises on the web. And so React Strict DOM is another attempt at the same problem, but from the other direction. So this time, we're starting from web code and trying to bring that to React Native. And you can see my talk at ReactConf for the whole vision. The vision's actually much bigger than React Strict DOM. It's just a small part of where React Native is trying to go, where basically in the past, React Native was fairly similar to the web, but there were things that it was just different for no reason. The CSS defaults were different and things were missing and features were missing. And so actually React Native itself is evolving to be much more aligned with the web and much more predictable in how everything works. But while we do that, and like while React Native improves, React Strict DOM is like this shim layer for now, where we are able to bring way more features to React Native from the web on a JavaScript layer. So we, just to give you a few examples, we bring support for CSS variables, media queries. We are adding support for some like DOM APIs as well. Like there's support for get bounding client rect, things like that. And so the idea is that going forward, as long as you use a somewhat modern subset of CSS, so there's efforts on way to like add grid layout and stuff to React Native as well. But like over time, hopefully you can write your app once, run it on web and native, and you won't have to like rewrite all of the things that are basically the same anyway. There'll always be some amount of rewriting, just to tailor to each platform, but you should be able to share more and more code between web and native.
I think that's a dream that developers are living with, right? More code sharing between both web and native. That's awesome. So is it open source? Can anyone contribute to it?
So so StyleX is open sourced in December. React Strict DOM was open sourced like 3 or 4 months ago. React Strict DOM is early, but it is functional. We are building with it today. And like there's a whole table there. So it's got a compatibility table that tells you what's supported, what's not supported, what's being worked on right now. So yeah, if it meets your needs, you can use it. And with a like web and native code base, it's always easy to like bail out and just make 2 separate versions of a component. So even if it doesn't fill all of the needs, it's easy to adopt incrementally.
Yeah, thanks. Okay, so let's move on to another topic. I think that's something changed the paradigm, the way we think about architecting the application, web application. I'm talking about React Server components. We had 2 amazing talks today. So my question to you is like, you would have seen React Server component very closely since the incubation, the design, and all these things. How should we think differently when React Server components come into picture for application architecture? Is like, people are thinking about like all in client, now things are going bit in server. There are a lot of memes also around about things going in server. Okay, let's not talk about those, but what's your view?
Okay, so there's like a long thing to think about here, but the first thing I want to say is, before you even like adopt server components, if you just read through like the architecture of how it's like telling you to architect your app, that's how most React apps should be anyway, which is that you should, there was like a controversy recently on Twitter, which is like, you can do render as you fetch or fetch as you render, and you should try to avoid fetch as you render. So fetch as you render is you render some components, then those components fetch some data, and then they re-render. So I don't think I need to even explain why that's wasteful, because like you're waiting to even starting to fetch your data, so obviously everything's going to be much slower. But React Server Components kind of takes it to the next logical step, where you can start fetching your data while you're still on the server. So your server rendering, you start fetching the data, and you render the things as they come along. And when you start, it's kind of similar to like Next.js's like loaders or like Remix's loaders. Like we've had some similar patterns in these full stack frameworks for a while now. So I would start with those. Like, do those make sense to you? And then React Server Components is like a huge optimization step after that. So if you're already fetching your data on the server, and a lot of your components are only there to just take the data that you fetched and render them into markup, and they don't have a bunch of behavior, it's like, why are we wasting bandwidth and time, like hydrating components that don't need hydration? Like, why are we spending time hydrating components that don't have any interactivity to begin with? And so React Server Components will be able to give you smaller JavaScript bundles, faster hydration times, and it's a huge improvement in like the architecture as well. But I don't want to speak too much on that specifically, because different frameworks actually are tackling that in different ways. So there's the Next.js flavor of React Server Components that's been out the longest, and React Server Components in Next.js is fairly automated. But it is also a big change from how Next.js used to work. So there's trade-offs. That was kind of going back to my talk. So here the trade-off was they try to give you the best possible model, but at the cost of more expensive migration. And then more recently, Remix has kind of shown a demo of what they are working on, where it doesn't give you like all of the like bells and whistles that you can get with React Server Components just from day one necessarily, but they have a really nice migration story where if you are using loaders, so Remix has the thing where you can have a component in a file, and in the same file you can have a loader. And in the past, the loader would fetch some data, return that data, and then that data would be used by the component in the same file. Now, the loader can just return JSX, because again, I like mentioned this in my talk, JSX is just data. So like the whole reason React Server Components work is because JSX is just data. And so Server Components decided that, hey, API calls can return JSON, but also JSX. And so that way you can just like move some of your code from your component into the loader and it just starts working. And so that will be a different architecture and one that is more easily adoptable in like incrementally. So there's many different things. The community is still figuring out like what will be the best architectures around it, but it does like fundamentally change a lot of things and removes a lot of burden.
Yeah, I think Naman covered a lot of it, but I want to give some historical context or like the background on the design for server components. Do folks here use GraphQL? Okay, quite a lot actually.
More than
Do you use Relay as well? Does anyone use Relay? No, one hand, 2, 3. Okay, that's about it. So we use Relay at Facebook, and Relay is a client library for GraphQL. And honestly, like server components was like, what if we wanted to bring Relay to React? What would that look like? And that's how server components came to be. So the best thing about Relay is it's basically just a data fetching library, but it has a compile step. So it lets you co-locate your data query with your component. But then it will run a compile step. It will scan all your components. It will figure out what are all the data dependencies that you need to render a single page, and then do a single query for all of them. So you don't really have any waterfalls in this model, right? Because you just do one request, which is very different from like your other data fetching libraries. And this is the secret sauce that we use at Facebook. And we were like, we want to bring this architecture to React. And then we came up with server components. That's the right way to do this, where it is more composable, right? Components are composable. That's the number one thing about React is how does this, every time I go to a design discussion with the React team, the first question that comes up is it composable? That is the one question that everyone talks about before we decide on any API. And server components is the composable alternative to Relay. So it's the way to do data fetching. It's data fetching for suspense, basically. If you think about suspense and how it integrates with server components, then you have now you have a good cohesive model. I don't know if you saw Naman's talk from earlier today. He talks about how some decisions make sense in the future when more things ship. And this is a prime example of that. A lot of people were like, well, we have suspense, which lets you read a promise. But how do I create the promise? Where's the data fetch happening? We were like, well, you can use useEffect for now. And then with server components, we've completed the whole story. You do the data fetching in server components, and then stream a promise down that you can use with the use hook. And that integrates really well with the suspense API. So that's the background for why server components.
Yeah, thanks a lot for sharing the insight. So I think no React talk is complete without talking about the hooks, and we know about the use API. So is it really the dead end for useEffect?
No, the use API is not a replacement for useEffect. The use API is just for reading resources that have been created outside render. So like I said, if you create a promise outside render, like in your server component and have it streamed down, you can use the use operator we don't call it a hook, we call it an operator because it doesn't follow the rules of hooks. You can call use conditionally, so it's not a hook.
It does replace use context. So use can like read different kinds of values, and one of them is promises, as Sathya mentioned, and if I'm not wrong, it also automatically suspends if you use a promise. So in the past, like I know like most of you probably haven't done this directly, but when frameworks like implemented suspense, they worked by like throwing a promise, which like use the error catching in React and uses like the proper API to cause suspense. Like we know how to like wait on things, but like how do you cause suspense in the first place? If you use a promise, it like causes suspense. The same way, if you do use a context, you can like read the value for context.
Cool. I think I see a time's up there. So the last question from my side is like, where do you see React going? I mean, you imagine that in 2025, we three are sitting here and folks are listening to us. What will we be talking about?
2025. Hopefully React compiler is stable and shipping by then. I think you can see more of like compilation based improvements to React. Like so the compiler is actually not just for memorization. That's just step one, right? Like the other step is already like the second part of the compiler is the ESLint plugin. It works, it gives you errors like warnings and linting. That's the second part. And as you can see, like there's more to the compiler than just this. So it's like a platform. So rather than thinking about it as a memorizing compiler, the way to think about it as that's exactly why we call it the React compiler, because we're gonna use this as a platform to build on from this.
So adding on to what Sathya is saying, I actually want to mention signals, which is one of the, like a lot of other frameworks use signals, and people think that signals are used because they're fast or they're basically event emitters. So like what makes them the thing that everybody's using? And it's basically an easy way for a framework author to figure out the data flow in an application. And to do that, there's like other trade-offs that they have to make. The React compiler gives React the ability to understand the data flow in an entire React app. So we get that same capability that like Signals gives you without losing all of the benefits of the React's like functional model. And so for now, it's using like memoization, but because we understand the entire data flow, like I can imagine all sorts of like really crazy features that are like nowhere else right now. So like we mentioned relay, and we have server components. But if you see server components today, there's still a certain amount of being careful to use it correctly, where you have to hoist data fetching up to make sure that you're not like waiting on one data fetch to then trigger the next one. And with something like the compiler, more and more of that would become automatable, where you won't have to opt into a full system like Relay, although if you do that, it's probably still going to be a great system. But it'll give you the ability to compose functions together and maybe hoist them for you, or at least detect them. I see like an explosion of tooling coming in the next 5 years of React.
Awesome. I got many more questions to ask to these two gentlemen. I'm sure you also. So catch them anywhere outside in the break. And thanks a lot for giving all this insight. I hope you enjoyed. And if you did so, please give a clap for these two. Thank you very much.